Hi, everyone. My name is Warren Patori, and I'm here today to present the Human Factors Group for UPRTA. So a background about me, I spent 10 years at the Florida Institute of Technology, earning my master's and PhD in aviation, and had the privilege of spending 5 years as a professor teaching the same courses I took as a student. I now work as a first officer piloting the Boeing 737 for Avello, and I volunteer my time with UPRTA as well as the NBAA on loss of control in flight and promoting UPRT. I have an excellent human factors team that I'm going to introduce, full of qualified pilots. A close friend of mine, Alex Padilla, who also earned his PhD from Florida Tech, currently serving as a first officer with NetJets, as well as volunteering his time with the NBAA. 2 ATP-rated captains, Paul Rogowski of Delta Airlines, retired from the U.S. Air Force, and Josh, Endeavor Air Captain, a part of the U.S. Helicopter Safety Team and a community member of the Human Factors Working Group, as well as Anne Marie Houston, a qualified pilot and research associate. So today, as an introduction to our Human Factors Group, we want to cover our goals and purpose with UPRTA, as well as provide the listeners with definitions on human factors terms and an introduction to 2 specific human behavior models. So our role within UPRTA is to provide the other working groups with a curriculum of human factors. Think of us as the human factors flavor that's going to be added to any project or initiative the other working groups are currently working on. The other purpose of the Human Factors Working Group is to verify any data collection measure that's going to be used for future projects, whether it's collecting historical data or collecting new data in the form of a survey. With the academic background we have in the Human Factors Group, we want to make sure those data collection methods are both valid and reliable. So in human factors, it's imperative that we're all on the same page when discussing terms. So today, as we break down these different terms and definitions, we're using standardized FAA terms from advisory circulars, regulations, and safety reports. So a very difficult question to ask on the spot, even for me, would be, what is human factors? So this is a multidisciplinary field. It's not just one thing. We're talking about psychology, engineering, design such as ergonomics. We're talking about the human being and their capabilities, strengths, and weaknesses or limitations within an environment, as well as their interactions with other personnel, their immediate environment, such as the flight deck of an aircraft, or the external environment, the airspace, meteorology, terrain, and then the equipment at their disposal, the tools and technology that they can use effectively. So if we know the human component or the human factors, we also have to talk about when things go wrong. And this was a topic I loved teaching at Florida Tech, particularly at the private pilot level, the very first course our students take. What is the difference between a hazard and a risk? Well, the FAA defines a hazard as a cause or contributor to an accident or incident. And if you can understand a hazard, a risk is the measurement applied to that hazard in the form of likelihood and severity. How likely is that hazard to occur? And if it does occur, what is the severity? So knowing these definitions, human factors, hazard, risks, we can move into something a little bit more in depth. And this is an example of human factors. It's not just enough to say, well, the pilot did this. We need to know why. And the why is going to come in the form of a theoretical framework. We can describe the human behavior in that environment. So today we're going to discuss HFACS. This is known as the Human Factors Analysis and Classification System. This is heavily based on Reason's Swiss cheese model, which every pilot is familiar with. So of course, the Swiss cheese model, we have those layers of defenses, but even a perfect defense has holes. And if those holes happen to line up, and a series of latent and active failures occur, an adverse event can take place. HFACS takes that well-known Swiss cheese model and brings it into the applied world. And we're able to use HFACS either preemptively or more likely post hoc after an incident or accident has taken place to identify causal factors. HFACS is so in-depth, we can identify 19 different families of causal factors within this one framework. Too large to fit on the slide today. So instead, we're looking at the 4 main pieces. And I just want to give an example of how 2 of these families of causal factors can be broken down into more specifics. Again, thinking if an accident or incident takes place and analyzing it post hoc. So with preconditions for safe acts, we're looking at the physical environment the pilot is located. What tools and technology would be available to the pilot or to the human? That last block that says unsafe acts. Was there an error or a violation that took place? Two very different causal factors. With errors, was it a decision-making error? Was it a skill-based error? Was it a perceptual error or a violation? Was this an exceptional violation, a one-time event that took place? Or is this routine, a normalization of deviance repeated multiple times? So that's just a taste, an intro to the HFACS framework and an example of how a proven theoretical model can be used to describe human behavior. We're going to repeat the same process for a second term that we'd like to define today, which would be UPRT decision-making cues. And again, we're going to take that term and break it down into more specifics using FAA definitions. So decision-making, we use the term every day, but how would you define decision-making? Outside of aviation, it's more common to use conventional decision-making. And this is subjective. It often involves experience and intuition, that gut feeling, which doesn't work quite as well in the aviation context. So of course, in aviation, we use ADM, or aeronautical decision-making. This is structured. It's a systematic process which is designed to decrease human error and improve safety. So with decision-making defined, let's take that word cue. And this is a human factors term. A cue is a singular piece of information that the human, or in this context, the pilot, is using to form judgment. And you can more clearly define a cue as visual, auditory, tactile, and vestibular. So in the context of the flight deck of an aircraft, there are multiple cues happening simultaneously, and they're utilized when a pilot needs to make a decision. So we have the term defined, and the model that we chose today, I remember learning about this during my primary flight training. It's known as the OODA Loop. And this was designed by the US Air Force for pilots to enable them to make effective decisions to gain a strategic advantage over their opponent. And it's a continuous cycle, starting with observing. The pilot is gathering information from their aircraft and from their environment. They're orientating themselves. So they're interpreting that information. They're interpreting those cues within the context of their environment and within the context of their situation. The decision is now made, or they're choosing which course of action to take. And once that course of action is chosen, they make the decision, they take action. The most important part of the OODA loop is that it is a continuous process, because once a decision is made, more than likely, new information is generated. And now there's a need for another action to take place. So unlike the decide model that we're all familiar with, which is singular, one decision, and it's linear with a clear end, the OODA loop continues. I can't remember conducting any flight myself where only one decision had to be made, whether it's a routine flight or something unexpected occurs. The OODA loop is a continuous process that is repeated until the very end of the flight. So once again, with decision-making cues defined and now supported by a theoretical framework. So I want to conclude by saying this is just a taste of what the Human Factors Group will be working on with UPRTA. We've taken terms that on their own pilots may be familiar with, but we've defined them using standardized FAA resources and backed or supported them up with proven theoretical models. Today we talked about HFACS and the OODA loop. And going forward with future initiatives, we'll be using these two models plus many others to more clearly define and describe human behavior. Our long-term goals is to support the other working groups. We're going to be that flavor of human factors added to any initiative that UPRTA is working on, as well as validating and venting any method of data collection that UPRTA is going to use, whether it's collecting historical data that already exists in the industry or collecting new data that has yet to be analyzed.